In this video, we are going to see the queue. So queue is a linear data structure. Under this video, we are going to see what is queue. Then we will see what are the operations we can perform on the queue. Then we will see the types of queue. Then we will see the implementation of queue and then application of queue. So queue is an abstract data structure or abstract data type. It is similar to the stack, but in the stack, we are inserting from only one end. But in the queue, we are doing the operations on both ends. In the stack, we are doing the operation from only one end. That is removing, we are doing from one same end, and we are adding from the same end. But in the queue, we are removing from one end and we are adding from another end. One end is always used to insert the data and other end is used for removing the data. Queue follows first in, first out. Means whatever the element you are inserting first, that will get removed, that will be served first. That is totally opposite to the stack. In the stack, whatever the element you are inserting first, that will be served or that will be removed at the last. But in the queue, this is not the case. Whoever come first, that will be served first. So that is first in, first out methodology. Data item stored first will be accessed first or removed first. So this is what the representation of queue. In that, now as the stack, in the stack we are using one chop. So same way in the queue there are the two important things, that is front and rear. So front is always point to the beginning and the rear will point at the end. So rear is used to insert the element and front is used to remove the element. So here we are having one example that in 10, 20, 30, 40. So whenever you are initially this front and rear is pointing at the -1. Suppose this is the array. And whenever you are inserting the element at that time, at the first time, the front will be increased by 1 and the rear is also increased by 1 and it is pointing to 10. After that, if I am insert 20, the rear will be increased by 1. After that, I am inserting 30, the again rear will be increased by 1. Whenever you are increasing, again insert 40, the rear will be increased by 1. Whenever one more, if I am inserting 50, the rear will be increased by 1 and 50 will be inserted here. So this is what the way of behavior of the front and rear. So these are the basic operations on the queue. In queue means you are inserting the element in the queue. GQ means you are deleting the element from the queue. Peek, you can check which element is going to be deleted. Useful, it is not removed, only it will return which element if you perform the delete operation or DQ operation, which element will be deleted. So that will be returned by the peek. It is not removed from the queue. Useful is the function which is used to check whether your queue is full or what. If you are going to insert the element, that queue should be empty, or empty in the sense that it should have the place to insert the element, right? So, and the last one is full. Is full means what? In this case, if you want to insert, there should be the element, there should be the place in which you can insert. And is empty means what? There should be if the queue is empty, you cannot remove from the queue. These are the types of queues. Basically linear queue, then we will have the circular queue, then we will have priority queue, and the last one is GQ. So first of all, we will see the linear queue. So linear queue is nothing but the same as the array. We are having one array in that we are maintaining two variables. One is front, one is rear. And in this case, once you are inserting, the rear will be increased by 1, and once if you are deleting, the again front is also increased by 1. Let's see how. Queue is an ordered list in which items may be added only at the one end called rear and the items may be removed from the other end called as front. Means if you want to remove, the 10 will be removed, and if you are inserting, the element will be inserted after 30. So in this side we are inserting the element and in this side we are deleting the elements. See in queue. Now if I want to insert 30, so 30 will be inserted here. After that, if I want to insert one more 30, so I am increasing the rear first. The first step is what? Increase the rear, and then 30 will be inserted in again. So this is what the first step means. First of all, check it whether queue is empty or what, full or what. If queue is not full, then increase the rear and insert the value. In the delete also the same case. Whenever you are deleting, first of all check whether your queue is empty or what. If your queue is empty, you cannot delete. Okay, if your queue is not empty. So in that case, you need to increase the front and return this 10. Now in this case, if I will call the GQ function, now queue is not empty. You need to return this 10 and the front will be increased by 1. So here, see, front 10 is removed. Again, if I am deleting, front will be increased by 1 and now it is pointing to 30. Now we cannot insert in the queue because the queue is full. Now here, I want to insert one more element. But where the rear is reached at the last. So if the queue is of size 5, the rear reached at the 4th index. Now here is no place. So you cannot, but yeah, you are having the place here for inserting, but it is not allowed because it's a linear queue. So you cannot insert the element even though there is a space in this particular queue. So this is what the drawback of linear queue. So because the rear cannot increase ahead, but still there is the two places. So in this case, we are using this particular drawback is removed using the circular queue. Now linear queue, what is the condition to check whether the queue is full or queue is empty? If your queue is and front and rear is pointing to -1 means what your queue is empty. That is totally empty. So condition is for empty. If rear is double equal to -1 means what your queue is empty. For the full, if your rear reached at the last index, that is the 4th index, means what your queue is full. So here the queue is reached, the rear is reached at the last, that is size -1. If the size is 5, 5 minus 1, 4. The rear is 0, 1, 2, 3, 4. The rear value is 4. So index of, that is index, rear is holding the index, that is 4. So 4, it is full, yes. So here also the rear is having the 4 value, therefore it is full. Still it is having the two blank elements or two blank spaces. This particular drawback we are going to remove using the circular queue. Circular queue. Now in the circular queue, it is same as the linear queue. Here is also we are having the NQ and DQ operations, but we have removed this particular thing from the circular queue. See, if we inserting in Q1, so 1 will be inserted. In Q5, then 5 will be inserted. Then in Q7, see, rear is increasing. 7 will be inserted. And whenever you are removing, this front will be removed. Goes front DQ. So from the front, this 1 will be deleted and front will go to 1. See here, 5. Now NQ again. So here this particular thing. Here you are inserted all the elements. Now here what you are having, here you are having the queue as a full because you are at 0 place inserted, 1 place inserted, 2, 3, 4, 5, 6, 7, 8, 9. All elements are inserted in the queue. The queue is now full because rear is pointing to the 9 and there is no place. Now suppose I am deleting two elements, DQ, DQ. So in the GQ, so here 0 will be deleted. From the 0th index, 1 is deleted, and from the first index, 5 will be deleted. Now the two spaces again there in the queue. Now if I'm writing in queue, in that case, so rear will be increased by 1, and then you can insert 22C here. So that is what the thing we can do in the circular queue, which is not possible in the linear queue. Even though the rear is at 9, again I can insert at the 0th index because 0th index is empty. So here I am inserting 22. Again 50, here I am inserting 50. So here again your queue is full. There are the two places empty, you can insert two elements. So condition for empty is rear is equal to -1, front is equal to -1. If the both are -1, means what, your circular queue is empty. Condition for full. So this is first condition of full. If the front is at 0 and rear is at size -1, this is again the full condition. So this is also full condition, right? So here you cannot have the value. So in this case also means what? There are two conditions, either this or this. The rear is equal to front -1. So rear value of rear is 1 and the front is 2. That is, in this case also the queue is full. Applications of queue: single shared resource. If you are using the single share resource which is shared by many of the peoples, in that case we are going to use queue. The simple example, we are using the taps in our colleges or in the offices. If anyone is using the water tap and then if you want to fill your bottle, you need to wait. So that is what the single resource. Or printer is also one common example in the offices. Whenever you are giving the print, at that time your job or your document is in the queue. If someone has given the print first, then that print will be given out and then your print will be taken out. Queues are used for asynchronous transfer of data. The data is also transferred in the queue. First, then second bit, then third bit, and then fourth bit. Like you are used to maintain the playlist in the media player. Media player you are having, or in the mobiles there you are having this playlist. So in that, this after this after this after this in this. The queue is also maintained in the toll booths on the highways. So those who are came first, they will pay the toll and they will go. But those who came late, those who at the last, they will pay at the last and then they can go. Queues are used in operating system for handling the interrupts. Queues are used in operating systems. There are many things which you can do with the queues. So everywhere in the real life, the queue is used. Priority queue. So priority queue is nothing but one queue in which you are following or you are having the priority for that particular job or for that particular data. It is not this case that always whatever they inserted at the last, it should be served last. No. So there are some cases in which we need to give the priority, and then according to the priority, you need to insert the element according to that. So here, it is not maintaining the order in which you are inserting the elements. It is maintained using the priority. If that particular element having the highest priority, it will be inserted at the first. And if that element is having the lowest priority, it will be inserted at the last. So that is what every item has priority associated with it, and the element with a high priority is dequeued before the low priority. We will see this priority in the next video. Thank you very much.